Okay. Hi, Dr. Rodriguez. My name is Jackson Nesin-Perna. Here is the card that we're supposed to show for the start of the presentation. Here's my notes that I'm just going to be checking quickly if I need to get a place in the presentation as to where I'm at. So, the presentation I'm going to be doing is on acidosis syndrome today. Acidosis syndrome is a increase or decrease in the blood pH, so it's becoming more acidic, and it's outside of the normal range of pH, which is between 7.35 to 7.45. So the way you test for this is with a arterial blood gas analysis. There are two types of acidosis generally. There's metabolic acidosis and then respiratory acidosis. The difference between these two, so they share a lot of similar symptoms, which are like when it's more mild, it's like it could be a nausea, fatigue, or vomiting, and then when it gets severe, it can progress into serious um, circulatory failure, shock, and even death. And the reason for that is because the blood and the circulatory system functions in a very specific um, pH range, and so when you're not in that range, then the like compensatory mechanisms that allow you to manage your blood pressure fail, and your body's ability to basically manage homeostasis and remain in a homeostatic kind of balance fails, and so then you progress if you don't correct for the acidosis. The difference between between metabolic and respiratory though can be seen in the breathing actually. So metabolic acidosis is characterized by I believe it's called Kussmaul breathing, which is a compensatory mechanism because the way that carbon dioxide is transported through the blood is it's transported as bicarbonate, but when the blood is becomes more acidic, it starts becoming carbonic acid because bicarbonate is just like a it's a ion that just becomes carbonic acid when it gets two hydrogen atoms, and so the or I guess it's one hydrogen atom, I believe. But anyway, so the it's very important that you notice the breathing because the breathing says so if you have Kussmaul breathing, it's showing that the body's trying to compensate for the increased amount of carbonic acid in the blood by by breathing shallow and breathing more quickly to try and expel more carbon dioxide through the gas exchange in the alveoli in the lungs. And if there's not that breathing, then it's a sign that it would be respiratory acidosis, which is caused by a respiratory issue. So then we have other syndromes kind of in the organ system that would be similar to it, but can be differentiated out. So I only really found one technically. That would be another disease in the same system. That's like the opposite of acidosis, which is alkalosis. So alkalosis is if the blood pH becomes too basic or it increases above the 7.45 normal limit of the blood pH. That's a sign that the basically the opposite is happening. So you're going out of homeostasis and the blood's becoming more basic. So that's a different issue. Um, that's pretty clearly distinct from acidosis because you see that in your blood arterial blood gas analysis. There are also like underlying causes that will bring acidosis into like this like that will cause acidosis, and those can be distinguished from. So there's one common disease that leads to respiratory acidosis is chronic obstructive pulmonary disease, and so that you would have respiratory acidosis as a secondary diagnosis or a secondary disease to the chronic obstructive pulmonary disease, and so you would test for that first if you're noticing respiratory acidosis, and then you can find which one is like because normally you have to treat the COPD to be able to also you can also help with the compensation of the respiratory acidosis, but you need to treat the COPD as well. And then on the other side, for metabolic acidosis, you can have an AKI or an acute kidney injury, which would be causing your kidney to not be able to excrete the right amounts or regulate the acid in the blood properly, which would cause metabolic acidosis. So you have to find if the kidney's failing and you have an injury that you need to um, compensate for the acidosis, but also treat the AKI. So now for the three diseases that are directly involved, that are under this kind of acidosis umbrella, that are caused by other causes. I have three. So the first one is going to be diabetic ketoacidosis, which is basically a symptom or a secondary disease that's caused by diabetes mellitus. And so what that is basically you have too much. If you do not have enough insulin in your blood, you cannot signal to your cells. So diabetes mellitus is a lack of insulin in the blood, and so you're unable to signal to your cells that they can open their, or you can't signal to the GLUT4 transporter to allow for the cells to accept glucose from the blood. And so you build up a lot of glucose in the blood, and your cells don't have energy, so they rely on fats to burn for energy, which is less efficient, but that it works for them. But as a byproduct of burning the fats, you create a lot of ketone bodies in the blood. There's different types of them. I don't have the specific ones written down, but what that does is it causes a acidic shift in the blood, and it causes acidosis. So that'd be diabetic ketoacidosis. The next one is lactic acidosis, which from what I'm reading, I think it might be more complicated than this, but it seems like there's two kind of categories of this, which is like an acute lactic acidosis and then a chronic lactic acidosis. The chronic one seems like it's caused by maybe like a liver failure or some type of kidney disease, and so you're not able to effectively clear out lactic acid from the blood if you do exercise, or if you're just having trouble with delivering or perfusing different tissue. And then there's a type A. So that was chronic is like the type B, and then the type A is an acute, it seems like, which is if you have a severe trauma, if you have circulatory collapse, if you have shock, it can cause a buildup of lactic acid that's not properly taken away from the cells. And so when you get either reperfusion of the tissue or just general bad perfusion or stable, if you get partially stabilized from a shock, then it can lead to this acidosis because you have all this lactic acid metabolites that are in the blood that can cause more issues, because the acidosis prevents you from regulating your body once you even recover from the shock. And it can cause a secondary one, it seems like. The third I have to talk about is renal tubular acidosis. And it seems like there are a couple different ways things can go wrong with this, but it's different from an AKI because it's not an acute injury. It's the cells in your kidney are slowly, or they're deteriorating to the point where they can't properly regulate different aspects of the blood and the acid exchange. And so there's different parts of the kidney that act on this. So there's the proximal convoluted tube and the distal convoluted tube, and I believe it was the proximal that's responsible for transmission or regulation of acid, versus the distal convoluted tube is responsible for the management or the regulation of bicarbonate. And so they do two different things, and depending on if you have an issue with the proximal or distal, it can cause different issues. And then there's also, I think there was a fourth type as well that I was reading about, which was that you can have a resistance to aldosterone as well, aldosterone is a hormone that's produced by, that's a signaling mechanism in the ROS pathway. And so if you are resistant to aldosterone signaling, it can cause you to not properly regulate your acid in your blood, which can lead to metabolic acidosis, which would be secondary to the renal tubular acidosis. So I think that's it today. I think that's all the topics that we're supposed to talk about. Thank you very much. Have a nice day.